back to Echo Live, coming to you from the Michigan Science Center's Echo Distance Learning Studio. Even though we are closed to the public this week, that doesn't mean that we're going to stop doing science altogether. So I hope you guys are ready to try our next set of science experiments. Now, this week we've talked a lot about atoms and molecules. And so today we'll be using that same science we've been talking about in order to, hang on. Sorry about that. Guys, let me pause my video. There we go. All right, we are going to be experimenting with our vacuum chamber right here inside our studio. We'll be placing things under the power of a vacuum. Now, when I say vacuum, I don't actually mean a vacuum like this or even like a vacuum that you might have inside your home for cleaning. Even though we'll be using a vacuum, we're talking about a vacuum in terms of matter. We are talking about vacuums that exist when we remove all of our atoms and molecules from an environment. This chamber right here is going to act as our vacuum chamber. And using this pretty powerful vacuum, we'll actually be pulling all of the air molecules out from the container, leaving nothing behind. That could give us some pretty interesting effects on some of our items that we've got here on the table in order to try out. Now, again, during this program, you guys can interact with me over the chat. So if you would like to tell me in the chat that you're here so that I can see people are paying attention, that they are ready to answer some questions, ready to ask some questions as we go ahead, tell me in the chat where you're watching from and maybe what grade you're in if you have some kids watching from home. Now, we'll be starting with these water balloons, and there's actually no water inside the balloons right now. I've just filled them up with air. Air is a gas, as we've talked about this week. If we were to base it on our states of matter, we would say that this air is a gas, at least at room temperature. Now, the balloons are full of a gas, but we'll be removing all of those air molecules from the container using this vacuum platform here. So if we flip our container over and create a tight seal on our vacuum chamber, we'll then turn on the vacuum. It'll be a little loud, but hopefully you'll still be able to hear me over this pretty powerful vacuum pump. Now let's take a closer look at our water balloons and see what happens as we remove the air from the chamber. Now I've only turned the vacuum on for less than a second, just to see what we get, what kind of effect we get. And the balloons are already starting to grow. You'll notice. So we'll turn the vacuum back on and let's watch what happens next. Our balloons almost entirely filled our container. So let's think about what's happening to these balloons. We said that we've removed the atoms and molecules from inside the vacuum chamber. We've taken them all away, leaving nothing behind but a vacuum. But there is still air molecules inside the balloon. Now, we talked about solids, liquids, and gases throughout this week. We said that as our states of matter change from being a solid to a liquid to a gas, they take up more and more space. That's because gas molecules want to expand. They want to be as far away from each other as they could possibly get, which causes them to expand, to fill that empty space that's left around them when we turn on the vacuum. Now, let's turn it on. We'll try to pop at least one more balloon here. Now, my very favorite part about these experiments with our vacuum chamber is actually what happens when we let the air back inside. So let's see what happens next. Our balloons go flying all over. Our blue balloon returns almost to its original volume or its original size as those molecules are forced back inside by the air pressure all around it. Now, I also have a beaker full of water. Now, I did dye it with some food coloring just so that we'll be able to see it a little bit easier on camera. Now, I've also placed a thermometer down inside our beaker here. And you may not be able to read it, but I'll make sure to give us an accurate reading as we go. Right now, our water temperature is about 20 degrees Celsius. So our temperature is set at 20 degrees Celsius. That is our water at room temperature. Now let's go ahead and we will remove the air from inside. And this one is pretty cool. So our air is being removed. And we'll see if we can get a closer view. All right. some motion, and pretty soon you guys will even be able to see that at home. All right, there we go. Now, you guys at home might not be able to see the temperature on our thermometer here, but the temperature inside the water is actually slowly starting to drop. And now if you watch the water carefully, we are actually observing a phase change. If you think back to talking about our liquid nitrogen, which we said would boil at room temperature, we're actually using this vacuum in order to cause water to boil at room temperature as well. Since we're removing all the air from inside the container, those water molecules are starting to have more space to move around. As we decrease the pressure inside the container, we actually increase the boiling or decrease the boiling point of this water. So now the temperature of the water, if I look at it closely, is closer to about 16 degrees Celsius. So we've actually dropped the temperature inside by about 4 degrees. This makes a lot of sense because if we think about removing atoms or molecules from this system, we're also losing energy. So those gas molecules that were in the air and the water molecules that are now starting to evaporate and turn into a gas and be pulled out by the vacuum, those are leaving the system and they're taking their energy with them. So as they take their kinetic energy, that energy that causes our gas molecules to bounce around the room, as we take those away, all we're left with are those slower moving water molecules, which are actually much lower in temperature. Now we'll zoom back in because we'll have a pretty interesting effect when I let the air back into our vacuum this time. So here we go. We see our balloons go flying, but we also see some condensation on the side of our glass. So we did have a major temperature change and a pretty cool experiment. Now, I'm not sure if anyone happened to catch the news this morning, but we did try out another very fun science experiment using some materials that I have on my table. So think about all the things we've talked about so far. Think about what's happened to these gas molecules as they've been exposed to our vacuum chamber. The next thing we're going to put inside are actually these really sugary, fluffy marshmallow peeps. So these are made out of marshmallows, and marshmallows are actually filled with millions of tiny air pockets. You can actually think of those just like our water balloons. Think about each one of these peeps having millions of microscopic water balloons inside them. So we'll put our peeps down on our vacuum chamber here, remove some of our debris. Now, I'm not sure if anyone out there is a big fan of peeps. I certainly am not. I think they're a little bit too sugary, but if you're not a fan of peeps like I am, I have a pretty special surprise for you guys as well. So we'll place the lid back on our vacuum chamber, make sure we're all plugged up, and turn our vacuum on. Here we go. Our peeps are starting to grow, just like our water balloons did as we've exposed them to the vacuum. Since we're removing the air from inside the chamber, we're giving those air molecules inside, or those tiny little pockets of air, more room to expand. But you'll notice we reach a point that the peeps actually start to deflate or start to lose some of their size that they had grown to. That's because we're actually ripping out each of those little water balloons, just like we saw our water balloons pop underneath the force of the vacuum. Some of those air pockets are being pulled out of the peeps, and it's leaving us behind these kind of smaller birds than we saw at the very beginning of our experiment. Now, if I turn off the vacuum, they'll maintain their size for just a moment here until we reintroduce the air back in. So think about the fact that we've popped many of those millions of air pockets inside, only leaving some behind. Now we'll go ahead and we'll reintroduce the air, and let's watch what happens next. We have squished down our tiny little peep birds. Now they don't look so appetizing. I promise I haven't changed anything about their chemical structure, so they'll still taste pretty delicious if you're a fan of peeps. But since we've removed so many of those air pockets from inside, all we're left with are these kind of deflated, almost like squished up, empty Capri Sun peep birds. So I have a time to pause for questions while I prepare an experiment that you guys can try at home. So if you have any questions about what we've done so far, maybe suggestions for things you might like to see, go ahead and type those in the chat. And if you'd like to try a vacuum experiment at home, all you'll need is a vacuum and a garbage bag and parental supervision. So for this activity, we're actually going to be vacuum packing a volunteer. And since the Science Center is closed, my pickings for volunteers were a little bit slim, but I did walk over to Kidstown and I grabbed one of my favorite friends, Pete the Penguin. Now, Pete the Penguin has very bravely volunteered to be vacuum packed, to experience the force of air pressure pushing down on his body. Now, this is an experiment that you can try at home, but you'll definitely need an adult to help you. It is their vacuum cleaner, and so they need to give you permission. And you'll also need someone to help you with this if you'd like to feel the force of air pressure. Now, all around us, there's about 14.7 pounds per square inch of air pushing on our body. If you think of a quarter, that's about 1 square inch. And then also imagine a 15-pound bowling ball pushing on that quarter. And those quarters are all over your body. So that's how strong air pressure is. Thankfully, there is an equal amount of air pressure inside our body as outside our body, so we really don't feel that pressure. But we can change that using this very safe experiment, using just a garbage bag and a vacuum cleaner that you have at home. So we have a vacuum tube here and a different type of vacuum, a little bit more powerful than the one that we've been using so far. And this one will be quite loud, so I'll try to keep it away from everyone's ears. To replicate this experiment at home, you'll need to hold the vacuum close to your body and also protect the end with your hand. You don't want to stop the suction, but you want to make sure that a vacuum bag doesn't get sucked inside. Otherwise, your experiment won't work. What we'll be doing is removing all the air from inside the garbage bag so that we can see that force of air pressure pushing down on Pete the Penguin. So if we have him hold onto our vacuum cleaner here, and then I create a tight seal around his body. This is where your parent would come in to help. We'll then turn on our vacuum and see what happens to Pete the Penguin. But we can see all of that air pushing on the garbage bag. As long as we let the air back inside, that pressure will equalize, just like we experience all the time. But if you were sitting in this bag, you would actually be able to feel that force of air pressure pushing on you. He kind of looks again like an empty Capri Sun, but Pete the Penguin is totally safe as long as you remember that the bag should never go over the head of your volunteer, the person experiencing the air pressure, and as long as you have someone on the outside to help you control the vacuum. So thank you, Pete the Penguin. You are a fantastic volunteer. We'll take you back to Kidstown in just a few minutes. All right, I see some questions coming in, so let's take some time to answer questions before my very last experiment. I see some suggestions for some fun things that we could put inside our vacuum chamber. I'm seeing some suggestions for fruit like apples or a piñata. Those are definitely things I think we might want to circle back to vacuum science a little bit later on during Echo Live. So we'll keep these suggestions in mind, keep sending them in the comments. And then we will try to have another segment where we can try out some of these ideas. I don't quite have an apple with me or a piñata, but those are great ideas. And maybe we'd have something really cool happen. Let's see, where did we get the vacuum? So the vacuum for the vacuum packing demo that you can try at home would work with any household vacuum. This one is just a small portable one so that we can take it with us on the road. This oil-powered vacuum is a little bit heavier, and we got this from our facilities team here at the Science Center. So I don't recommend getting one like this. The power on it actually isn't that great for this type of demo, but you'll just want to use the same vacuum that you'd use for vacuuming up the floors at home. All right, I see some great questions. I see a lot of cheers for Pete. Thank you guys for being so encouraging. I promise Pete definitely wanted to volunteer for this. I pulled all the animals in Kidstown and he definitely had the most excitement. All right, so we are going to, let's see. How many things can you put in the chamber? Well, we're pretty limited by size, but you'll see that on this chamber, we've got some different sized rings, and this one actually just fits in the very smallest. So we're not really limited by the power of the vacuum for this demo. We're really limited by the size of the container. So maybe for our next segment, we'll look around for a larger vacuum container so we can try fitting even more balloons or maybe some more ice cream. I see a suggestion for ice cream. That could be pretty cool. All right, so we'll keep those things in mind. Thank you guys for your suggestion. Now I have one very last demonstration to show you guys. And the reason we do this last, it is by far the messiest. So I brought with me some shaving cream. And if you've ever used shaving cream before, you know that when you spray it out of the container, you hear this noise. And that's actually the pressure inside this container creating, again, all those tiny air packets inside the foam. So we'll put just a small amount down in the bottom of our beaker. And then we're going to put this inside our vacuum chamber. Now, this is going to make quite a mess, so this is the last thing we'll be able to put in the vacuum chamber for today. But again, we'll come back to this one. It seems to be a lot of positive comments, and it's definitely been one of my favorite things we've tried so far. So let's go ahead and we'll zoom in. And we'll go ahead with our very last vacuum demo in 3, 2, 1. All right, and again, as we introduce the air back inside the container, this is the best part. We've made a huge mess. So that is about it for our vacuum demos today. Again, at this time, if you do have any last questions, go ahead, type them in the chat. And during this time, we always, of course, want to thank the sponsors of the Michigan Science Center. So big thank you to DTE Energy Foundation and all of our other various sponsors who are supporting my site even while we're closed to the public. It's because of these funders that we're able to offer these free programs every day. If you guys enjoyed this, please share it on your Facebook page. We want as many people to get to experience these programs as possible. Share it with people who might have kids at home who just love science, maybe with your teacher friends who are looking to provide programming to their students who are off school at this time. And then we'll see you guys tomorrow at 2:30 p.m. Now let's see, check back if I have any new questions in our comments. I see a lot of comments that we liked the shaving cream. It smells really nice in here now. Could we put electricity inside our container? I have a pretty interesting experiment that we could try using an electric powered bell. We might try that one on our next vacuum segment. So yes, you can put things that are electrical inside the vacuum chamber. If we're interested in trying that, maybe send us a specific suggestion for something you might want to see. I see a question that space is a vacuum, right? That is exactly correct. The reason that we do a lot of these demos is to talk about the effects that might be on all of our equipment that we send into outer space. It's important to know how our equipment is going to handle the vacuum of space. There is no air around, there is no air pressure. And so we really have to think about the types of materials that we send into outer space. We clearly don't want to build our spaceships out of water balloons. We saw that that didn't go very well for our container right here. But that's why we test out a lot of these things here on Earth using vacuum chambers, is so that we're ready for when we send equipment into outer space, which is also a vacuum, empty of matter, including air. What would happen to meat in there? That's an interesting one. Something to consider, maybe before we try it live on air, but we'll think about that one. What if we put slime inside? You know, slime is another one of those substances that does have quite a few air pockets inside. That could be a really good experiment. They do sell smaller vacuum containers that are pump powered that you can actually buy at the grocery store for keeping your food preserved. I can show you guys in a different segment, or we might post an online video about how you might be able to use those smaller household vacuum chambers in order to try some of these experiments at home. Ooh, I see a question for, how did the balloons expand like that? But when I put the air back in, they all went back to the way they started. That's because I didn't actually change the amount of air that was inside the balloon. It started and stopped with the same amount of atoms and molecules inside the water balloon. When we removed the air from the container, those molecules were allowed to spread out. They had more space that they wanted to fill, and so they pushed apart from each other. When I let the air back in, we repressurized the system. And so the air pressure started pushing back on the balloon, and it just returns to its original size and volume. So we didn't change anything about the internal system of the water balloon, only the outside. So that's why it goes right back to the way it was at the very beginning. So we could put other liquids inside as well. That's a great question. We do water. It's pretty easy to make water boil, and it doesn't make a huge mess if it does spill over. See some great suggestions. Maybe we'll have to try about, ooh, an egg. I've never actually tried putting an egg inside the vacuum chamber. We might try that one out. Ooh, what about rubber? These are all, ooh, and a candle. A candle is a great suggestion. I can ask you guys a question that if you've ever put out a candle without blowing on it, maybe you've cupped it with something like a metal cup or one of those snuffing tools. So if you've done that before, you might know that as soon as you remove the oxygen from a combustion reaction, that you might actually put out the flame, right? Or you would definitely put out the flame because oxygen is one of those parts of the fire triangle. So we'll be talking more about the fire triangle tomorrow during Echo Live. And so if you're interested in the fire triangle or combustion and how it works, we do have some more demonstrations that we'll be trying live on air. You guys should definitely join in and try it with us. I see some great suggestions. I'm gonna, please keep these coming. For now, thank you guys so much for joining us. I'm always having such a great time with you guys, answering such great questions that you're answering or asking me right there in the chat. So I hope that you guys tune in next time for Echo Live. We'll be here every weekday at 2:30 p.m. And again, if you enjoyed this video, please share it with your followers on Facebook so that they can watch it as well. Thank you so much, everybody, and have a great rest of your day.